Hi, welcome to another video on MX7. This time we're going to look at the installation of the MX7 and the GAMS and then go through the process of how to calibrate the GAMS and some of the checks to make. Starting with top-down view. So if this is our vehicle, then I'll just put windscreen in here, and yeah, we can see the tires out the side here. So we'll have a roof rack of some description coming across like this. Now, as we mount the MX7, we want to make sure that as close as possible, we want the rack to be facing the direction of travel. So that when we've got this installed, then its axis that way, its x-axis, is the same as the vehicle's x-axis. Once we've got that in place, we're going to have we've got our reference point down here for making our measurements. We want to have our GAMS antenna, minimum of 1.5 meters ahead, and ideally if we could do a little bit further, but minimum 1.5 meters ahead. And really thinking about that fact that if we can, doesn't have to be on a straight line, so we can, if we, for instance, had something sitting out here, let's draw in another rack. If we had a rack somewhere out here at the front of the vehicle that we can mount the GAMS on, it might be that it's sitting over here. Then it's just a case of measuring as accurately as we can from there, as accurately as we can across this way, and then in the Z as well. So from the top down, that all makes sense. Then if we just quickly turn to side view for a second, and we've got our vehicle this way. Just get out of that, and we'll wipe out that. Keep it roughly the same as we've drawn it on the other one, something like this. So we had a couple of racks here and some sort of rack here at the front. And pop the MX system there and the GAMS there. So when we're setting this up, just an extra note here, we ideally want this, as we're capturing, to be level. That's why there's the adjustment plates on the roof rack. One of the easy ways of doing this is to get this parked on something that's nice and level as well, and then just using the inbuilt bubble, or if you wanted to put a builder's spirit level over there, and just make sure that we're getting that nice and level. If we're level down here, then it will make that initial measurement of getting the Z value of where this is in relation to, keep using the same color, so that's positive Z. The relationship of the GAMS to our reference point back here as accurately as possible. And that gives us our initial values that we key into TMI when we're capturing. And then we go to POSPac where we do some checks on those and we determine a calibrated value, and we'll jump over to that now. Over in POSPac now, we will start a new default project, and I've got my logging data from the base, and so I'll just drag and drop that in. Okay. And then I always like to come to import and navigate down to the directory. We go the MX7 data into POS and to RAW. Okay. And we'll take that first POS file and import that. So same as actual processing, this will trigger the ephemeris data to be downloaded. We'll just wait for that. With the ephemeris data downloaded, we then ask for the rover antenna type, and we'll just set that as the Talisman TW3870. It's worth noting that some of the MX7 systems do have a slightly different antenna, so worth just double checking that and loading an antenna file if needed so that yours will correlate to the correct antenna type. Now we have our vehicle reference frame. We want to calibrate the GAMS installation here. So what we're going to do is set this as our base station, and then we'll come to the project settings. Just bring those over. Now, lever arms, the primary GNSS lever arm, so it's the location of the antenna to the IMU origin point, that's been done in factory, very well known, very well determined, so we can set that down to less than 3 centimeters. If we come to the GAMS, we'll find these GAMS baseline vectors, and these won't be the values that you've keyed into TMI inside of the software to operate the MX7, because we measure from a reference mark, and then the offsets from that reference mark to the IMU origin point are applied, so that's why these will be slightly different. What we're going to do though is we're going to make sure that these are accurate. So we're going to set this to unknown, and we'll hit OK on that. And then we'll come to our, actually I'll hit save first, and I'll just pop this into new folder here. Okay, now we'll run the GNSS inertial processor, and we're just going to set it to Infusion single base. We're only running the one base. It's worth noting at this point as well, so we've relaxed the tolerance that we will allow the GAMS solution to differ by with that unknown setting on its calibration parameters. When we did this initial calibration run, went through all of the same starting and finishing maneuvers that we normally would, and we ran it in a clean environment for at least 30 minutes so that we get a well-determined solution for this initial calibration. Because I'm doing this in POSPac, I've got the option of smooth processing or just forward processing. I'm just going to run the forward processor in this instance for the calibration. Allow that to run. And so this is going to process the entire trajectory. It's going to try and resolve the location of that GAMS as well. So it's been given freedom to shift that where it needs to and converge on a reliable solution that matches the data recorded in the trajectory. Just on the first run, it's unpacking all of the GNSS data and giving us a quick check on how much of this it thinks it will be able to solve. So really not much time where there's any gaps or problems with the solution. So about 10 seconds. So, okay. And that will trigger the solution to start running. Okay, we've got our smooth solution running. And we'll just close out of that. Go to reports and display plots. And we'll have a look at the calibrated installation parameters. So these, because they've been set down to the smallest value, they're not allowed to shift at all. If we have a look at the GAMS though, where we've given it an unknown status, it's allowed to freely shift wherever it needs to then resolve a converged solution. So if we have a look here, we can always zoom into different areas. By about this point, we're looking like we're pretty well aligned. 1769, 177. Probably spends more time at about that 1769 than anywhere else. So we can record that, 1769. Here, same thing, variation at the start, and then we start to get this where if I go to about the same epoch, we're looking at 089, negative 089, and in the Z, you get more sort of variation and takes a little bit longer to converge on a nice reliable solution with the Z. You can see here we've done quite well and probably spends, if we come up to about that same area there, we'll go with 712. This figure of merit represents how well determined it is. And there's some other things we could have a look at, like just making sure, so down here, like you don't want to take something where you've got high PDOP values. If we're further out here, we're sort of converging towards that solution, making sure we're using it at the time. If we have a look at the forward processing parameters, we've got a really good solution out at that point. So where we've taken those values from seems reasonable. So we can close out of that. And this is where we want to iterate. So if I come back to my project settings, oops, and back to GAMS, then I just want to modify this. That one's by 1 millimeter. This one a little bit more. I had 8.9 as the solution there, and this one was 712, so 6 millimeters there. Nothing too significant, so we'll hit OK on that, and I'm going to hit save. Come back in here, and I'm going to run the exact same thing again. I'm going to run the forward processing again, just as a double check. And really, this just helps to make sure that I haven't keyed in anything incorrectly, made a typo when I've recorded those parameters. If we did start to key something in wildly wrong, then what we would see is a really huge deviation at the beginning there before it started to resolve to a converged solution. So just a sanity check on this run, and we'll let that operate. I'll hit pause on the video so I can speed it up a little bit. Processing is done again. We'll close out of that and we'll jump back to display plots. We'll have a look at our calibrated install parameters again. And 1769 seems to be where that one lands. 089 and 712. What do we get out to there? 713. So that's pretty good. Quite happy with that. Now, hit save on that again. And if I jump back to these project settings, go back to GAMS, I don't need to make any changes here, but what I will do now, because this was a run we might want to process against, is if we shift it down to 5 centimeters, it's going to allow some freedom in that solution when we process. If I shift it to 1, it's going to hold these really rigidly, like we saw on the primary antenna, where it's not trying to make any changes to that location. It's just saying, yep, these are exact, and we're going to use those throughout. So depending how confident you are in that solution, sometimes it's good to give it a little bit of freedom, but if we think that these are exact and down to that 1 centimeter, then what we could do is run this, and what we can then hit save, process. We could then run our forwards and backwards solution with smoothing. And what we'll see is when we have a look at the display plots, there won't be any variation in that GAMS value because we've constrained it right down. It's not going to shift. So I'll hit run on this, and we'll just check how this actually progresses through and operates. So now that's full processing backwards and forwards with a really tight constraint on the GAMS. I'll hit pause again, and we'll come back to this in a moment. Now with the forward and backward processing done, we can close this and go back to reports, display plots, and if we have a look at our smooth performance metrics just for the whole mission, looking pretty good. Down at 30 mil in the northing, 60 in the easting, just in that one spike, in the down direction. And so majority of our data collected, if we grab those three together, is down in this nice range where it's all sub 30 millimeters and the easting northing is sub 20 mil. So quite happy with that. Just checks that the calibration run wasn't done in a terrible environment. Could have been better. Maybe in future, try to do it somewhere that we don't get some of these other spikes going through. Then if we have a look at the calibrated install parameters, these primary values, because it's set as being less than 3 centimeters, we're not trying to make any modification of those. This figure of merit is an indicator of that this is of good quality. Then if we have a look at the X, Y, and Z for our GAMS, same thing because we've set that down to 1 centimeter, and the figure of merit progresses exactly the same through there. If we have a look at our GAMS solution down here, solution status, there's only this one occurrence where we have to drop the GAMS out of the solution entirely, and that's probably reflected here as well. When we see processing modes, we get that spike through there where we've had to drop out to a float solution. So just something with a little bit worse quality there. But overall, that seems fine. So I can close out of that. I can hit save. And then the only thing left to do, if this is the vehicle that we're putting the system onto and we want to have the calibrated parameters inside of TMI so that we don't have to manually key them in to here each time, is to apply the offset and to make these in reference to the reference mark location on the roof rack, which is what TMI software will accept. With that, we're all done. Hopefully this is useful to anyone installing an MX7 system onto a vehicle for the first time and going through the GAMS calibration process. Bye for now.